AI learning. Greetings. Welcome to my YouTube channel, and today we are going to learn AI technology, artificial intelligence and Python. The growing importance of AI. AI is transforming many industries from finance to healthcare to transportation. AI solutions are being utilized to improve efficiency and productivity across sectors. Many day-to-day products are now utilizing AI: smartphones, social media, streaming services, etc. AI makes these products smarter and more personalized. AI is helping automate repetitive and mundane tasks, allowing humans to focus on more meaningful work. It is augmenting human capabilities. AI advances like computer vision, NLP, robotic process automation are enabling new applications and experiences that were not possible before. AI is enabling businesses to make better data-driven decisions using predictive analytics and pattern recognition from big data. Fields like healthcare, education, agriculture are leveraging AI to improve outcomes and democratize access. AI is playing a growing role in scientific research and innovation, from material discovery to drug development to quantum physics. Governments worldwide are investing heavily in AI research and development, recognizing its benefits for economic growth. AI security is crucial for detecting financial fraud, monitoring cyber threats, enforcing law and order in the digital age. With the exponential growth of data, AI is necessary to quickly analyze and derive insights from this data efficiently. The bottom line is AI has applications across multiple domains, and its significance will only continue to grow as more innovative AI solutions are developed. Learning AI opens up tremendous career opportunities for students in this emerging field. AI course overview. Key topics that will be covered: machine learning, deep learning, neural networks, NLP, computer vision, etc. The course structure: number of modules, lectures, assignments, etc. The hands-on coding approach using Python and popular libraries like TensorFlow. Prerequisites and target audience that will benefit from this AI course. Here are some tips on covering prerequisites and target audience for an introductory AI course. Prerequisites: data analysis skills. Comfortable learning technical concepts. Ideally, some exposure to coding, math and statistics before taking this course. Data scientists and analysts wanting to expand into machine learning. Anyone motivated to learn AI foundations and work in the field of artificial intelligence. No prior AI experience necessary. This introductory course is suited for beginners who meet the prerequisites. Useful for both students and working professionals. Prior programming experience is desired. Experience with Python preferred, but any language like Java, C++ is sufficient. We will build on existing coding skills. Math, statistics and data analysis will be critical foundations for understanding machine learning algorithms. Lifelong learners who are curious about AI and want to develop skills to work in this exciting field will find this course beneficial. It will equip you with practical AI abilities. An overview of the tools, datasets and learning methodology that will be used. Skills students can expect to have by end of course: building models, coding fluently in Python, interpreting results. How course will equip them to take up real-world AI projects and progress in the field. Expectations on effort required in terms of dedicating time to lectures, assignments, and active participation. Conclusion. Key benefits and takeaways from the course. AI is the future. It's transforming everything from healthcare to transportation to banking. AI jobs are the hottest jobs right now. Learning AI will give you very sought-after skills and great career opportunities. AI lets you build cool things: self-driving cars, speech recognition, computer vision, etc. AI requires creativity. You have to think of novel solutions to challenging problems. AI is great for multidisciplinary thinkers. It combines computer science, psychology, linguistics, mathematics, and more. AI can make a meaningful difference in areas like healthcare, education, sustainability, accessibility. With AI, the possibilities are limitless. There are so many exciting innovations happening with AI across industries. AI doesn't require advanced math. AI is redefining what's possible with technology. Learning AI teaches you highly valuable skills like data analysis, critical thinking, problem solving. The key is tapping into students' curiosity, desire to innovate, and multidisciplinary interests. Convey both the cutting-edge coolness and meaningful real-world impact of AI. Get them excited about the endless possibilities. Thanks for watching, viewer. For interest, I invite you to subscribe YouTube channel and start the AI learning journey. Introduction to AI. Artificial intelligence, AI, refers to computer systems or machines that are designed to perform tasks that normally require human intelligence, such as visual perception, speech recognition, and decision-making. The goal of AI is to create intelligent machines that can act and react like humans. Getting started with AI. Don't need a technical background. Being curious and willing to learn are the most important things. Learn the fundamentals. Start with an introductory course or book on AI to learn basic concepts like machine learning, neural networks, and natural language processing. Some common AI focus areas are computer vision, NLP, robotics, etc. Join an AI community. Join forums like Reddit's R, Artificial and R, Machine Learning to discuss AI with other learners. Stay up to date on AI news. Subscribe to newsletters and podcasts to learn about the latest advancements. Gaining hands-on experience. Work on AI projects. Start with simple projects to get hands-on with data and tools. Kaggle has many datasets to practice with. Enter AI competitions. Compete in challenges on platforms like Kaggle to solve real-world problems. Consider an AI internship. Overall, go step by step, focus on fundamentals first, get hands-on practice, and stay curious. Introduction to AI. Explain what AI is in simple terms. Discuss applications of AI like self-driving cars, voice assistants, recommendation systems. Talk about the history and future of AI to generate interest. Machine learning basics. Explain key milliliter concepts like models, training data, testing data, overfitting and underfitting. Introduce supervised learning, regression, classification, and unsupervised learning, Clustering, dimensionality reduction. Do an in-class demo of basic milliliter models like linear regression, k-means clustering. Building an AI model. Walk through the workflow of building an milliliter model from scratch. Cover data collection, data preprocessing, feature extraction, model selection, training, evaluation. AI algorithms. Provide an overview of important milliliter algorithms like decision trees, neural networks, support vector machines. Explain the high-level working and use cases, no need to go into mathematical details. Share resources for students to dive deeper into algorithms they find interesting. AI applications. Discuss real-world AI application areas like computer vision, NLP, robotics, gaming through examples. Highlight AI innovations students can relate to like face recognition, chatbots, product recommendations. Encourage students to think of novel ways to apply AI for social good. That covers the key concepts and skills students need to gain an introduction to AI technology and pique their interest in pursuing it further.
AI, the future explained. Artificial intelligence is everywhere in today's world, from the smartphones we use to the cars we drive. But what is AI, and what role does it play in the future? In this 10-minute video, I'm going to dive deep into the topic and explain everything you need to know. So, buckle up and get ready to enter the world of AI. What is AI? AI is a branch of computer science that focuses on creating intelligent machines that can perform tasks that typically require human intelligence, such as visual perception, speech recognition, decision-making, and language translation. AI requires large amounts of data to learn from, and it improves itself over time. Types of AI. There are primarily three types of AI. First, we have narrow or weak AI, which is designed to perform a specific task. Secondly, we have general AI, which has the ability to learn any intellectual task that a human can. And lastly, we have super AI, which is hypothetical AI that surpasses human intelligence. Applications of AI. AI has a broad range of applications, from voice assistants to self-driving cars, and from chatbots to fraud detection systems. The future of AI. AI development is a continuous process, and it's rapidly growing with each passing day. AI has the potential to revolutionize the way we live and work, solve complex problems, and eliminate the need for human intervention in various fields. However, it also raises certain ethical, legal, and social issues that need to be addressed before it becomes a reality. Conclusion. In conclusion, AI or artificial intelligence is an incredible technology that has already changed our lives. From automating tasks to powering self-driving cars, AI has the potential to transform our world in countless ways. However, we must be cautious with its development and use it ethically and safely. If you're curious about what AI is and what role it plays in the future, then this video is for you. You'll learn everything you need to know about AI, its applications, and its impact on our lives. Buckle up and join the ride into the world of AI. Within this video, you will gain a comprehensive understanding of what artificial intelligence truly embodies and the significant role it will play in shaping our future. With a runtime of merely 10 minutes, this video efficiently condenses the vast knowledge surrounding AI and presents it in a concise yet informative manner. The video delves into the various applications of AI, demonstrating how it influences a multitude of industries such as healthcare, finance, transportation, and more. Furthermore, you will acquire a deeper appreciation for the impact that AI has already made and will continue to make on our lives. Discover how it has revolutionized the way we interact with technology, simplifying tasks and enhancing efficiency. From self-driving cars to virtual voice assistants, AI is becoming an integral part of our daily lives, streamlining processes and improving our overall experiences. So, if you're ready to explore the captivating world of AI, this video is your ultimate guide. Be prepared to witness the wonders of this rapidly evolving technology and uncover the endless possibilities that lie ahead. Join us on this exhilarating journey as we unravel the mysteries and discover the remarkable potential of artificial intelligence. Are you ready to take the plunge? Let's dive into the captivating world of AI together.
About linear regression. Here are some tips for teaching linear regression in an intro AI course. Explain regression as predicting a continuous target variable based on input features. Contrast with classification. Introduce the linear regression equation with coefficients, variables, and error term. Visualize it as a line of best fit. Use compelling real-world examples like predicting house prices, stock prices etc. Students can relate to these. Walk through an example linear regression model in class using Python and sklearn on sample data. Explain fitting, prediction, evaluation. Explain ordinary least squares as the method to learn coefficients. No need to derivations, focus on intuition. Evaluate model performance using metrics like ME, MSE, R-squared. Interpret values. Visualize results using a scatter plot with regression line overlay. Useful to build intuition. Cover model assumptions linearity, no multicollinearity, homoscedasticity, normality of errors, briefly. Extend to multiple linear regression with multiple input variables. Add dimensionality. Show how to prevent overfitting using regularization techniques like L1 and L2. Provide coding exercises to implement linear models, evaluate performance, and refine models. Contrast linear regression with other techniques like decision trees, SVMs, neural nets. The goal should be to give students a practical understanding of this fundamental supervised learning technique. Keep the math minimal and focus on coding and applications. IRIS dataset contains measurements of sepal length, sepal width, petal length, and petal width for 3 iris species Setosa, versicolor, and virginica. Data distribution using visualizations like pair plots and histograms. Highlight patterns and correlations. We discuss the characteristics that differentiate the 3 species based on the measurements. Setosa is separable while versicolor and virginica are harder. We introduce k-nearest neighbors algorithm and explain how it classifies new data points based on nearest training points in feature space. We walk through KNN model building steps, normalize data, find optimal k-value via elbow method, fit model, make predictions. We evaluate model performance using classification accuracy, confusion matrix, precision, recall etc. On test set, visualize decision boundaries for different k-values to show how complex they can get. Compare KNN performance with other models like random forest, SVM on this dataset. Explain impact of imbalanced data on performance and how to handle it through sampling. Provide starter code for loading data, splitting, normalization, model building, evaluation. Tweak k-value, distance metrics, voting weights as exercises to improve performance. The IRIS dataset is a great intro example for hands-on practice of a classification technique like KNN. Keep the coding simple and focus on interpreting results. Python script. Here are some tips for teaching students to write a Python script for image processing and computer vision. Import libraries. Import key libraries like OpenCV, NumPy, Matplotlib. Explain their purpose. Load image. Use CV2, ImRed, to load an image from file into a NumPy array. Preprocess image. Perform pre-processing steps like converting to grayscale, resizing, blurring, thresholding, etc. Explain why each step is useful. Analyze image. Use OpenCV functions like CV2, find contours, to detect edges, shapes, etc. in the image. Draw on image. Use NumPy array operations and OpenCV drawing functions like CV2, circle, to highlight detected objects. Show output. Display the original and output image with Matplotlib for comparison. Save output. Save the resulting image with annotations using CV2. I am right. Modularize code. Split into functions for preprocessing, detection, drawing annotations, displaying etc. Provide examples. Show examples detecting shapes, counting objects, identifying colors, etc. Coding exercises. Provide practice images and skeleton code for tasks like detecting cars in a street, counting coins, reading signs, etc. The key is to make it hands-on by showing code snippets, explaining each step, and providing sample images and starter code for practice. Emphasize proper documentation and functions to structure the code. Tell me more about Python program. Here are some tips for teaching students to create a Python program for sentiment analysis. Import libraries. Import NLTK, TextBlob, regex, Matplotlib etc. Explain their role in NLP. Load data. Load a dataset of text data like movie reviews or tweets. Explain sources for NLP data. Preprocess text. Clean the text by removing punctuation, stop words, lemmatization etc. Explain these standard NLP preprocessing steps. Analyze sentiment. Leverage the TextBlob library to perform sentiment analysis on the preprocessed text, explaining polarity and subjectivity scores. Visualize results. Use Matplotlib to create sentiment polarity distribution plots for positive, negative and neutral sentiment. Evaluate accuracy. Manually label a subset for testing. Report accuracy, precision, recall of model. Improve accuracy. Use techniques like n-grams, word embeddings, neural networks to improve accuracy. Modularize code. Split into functions for data loading, preprocessing, modeling, evaluation etc. Explore enhancements. Ideas like ensemble modeling, adding more training data, LSTM for sequence modeling. Provide starter code. Skeleton code for loading data, preprocessing, plotting, simple TextBlob model to complete. Emphasize going line by line and relating back to core NLP concepts. Sentiment analysis is a great beginner NLP task. You can make it as simple or advanced as needed for students' level. Tell me more about skeleton code. Here are some tips for providing skeleton code to students for AI coding exercises. Include all required imports at the top so students don't have to hunt for them. Define any key functions needed with descriptive names and doc strings, but leave bodies empty. Provide outlines and comments for important stages like data preprocessing, model training, evaluation etc. Leave placeholders for variables, file paths, hyperparameters that need to be set by the student. Include print statements for key outputs so students can check progress. Provide doc strings and comments explaining the purpose of each code section. Include code for loading any datasets or packages required for the exercise. Leave parts requiring logic like error checking, conditions, loops, model building to be completed. Include code for basic visualization like plotting regression lines, confusion matrices etc. With canned titles, labels. Make modular with separate functions for loading data, pre-processing, training model, making predictions, evaluating model, etc. Include placeholders for multiple model options like KNN, random forest, neural net for student to implement one. Don't write repetitive code within functions. Leave it to the student. The goal is not to give away the solution but provide a structured framework and scaffolds to support the students' learning. They will learn much more by filling in the logic and details. Milliliter models. Here are some additional tips on teaching machine learning models to students in an intro AI course. Explain the concept of training data, testing data, and validation data when building milliliter models. Use visual diagrams to make it clear. Cover the key steps in training a model. Feed training data, make predictions, compare to actuals, calculate error, optimize model based on error, repeat. Again use visuals, animations to demonstrate. Explain overfitting and underfitting with illustrative examples that students can relate to. Like studying too hard for an exam vs not preparing enough. Demonstrate how changing model hyperparameters affects performance using interactive visualizations. Implement simple models like linear regression, logistic regression, decision trees, KNN in class using Python, Sklearn. Show code and explain what each line does. Provide interactive demos for more complex models like neural networks where students can adjust layers, nodes, activation functions, etc. and observe effects. Do a model comparison case study between different algorithms on a dataset to show strengths and weaknesses of each. Explain bias-variance trade-off, overfitting, underfitting and ways to address these issues. The key is to balance theory with practical demonstration and interactivity to build intuition on milliliter models. Tell me more about neural networks. Here are some tips on covering neural networks in an intro AI course. Explain the biological inspiration neurons and connections in the human brain. Demonstrate how data flows through the network during training using visuals. Explain backpropagation and how the network learns by adjusting weights through gradient descent and loss minimization. Use interactive visualizations to show how tweaking hyperparameters like layers, nodes, activation functions, epochs, etc. affects model performance. Implement a simple neural network in class for a case like binary classification using Python, Keras to make it concrete. Cover different types of neural networks briefly. CNNs for computer vision, RNNs, LSTMs for sequence data like text and audio. Explain how techniques like dropout, regularization prevent overfitting in neural networks. Leverage educational resources like TensorFlow Playground to let students visualize neural nets. Avoid complex math and equations. Focus more on high-level intuition. Assign projects to implement neural networks on datasets like MNIST digits. The goal should be to give students a solid conceptual foundation on how neural nets work and learn from data. Hands-on implementation also helps demystify them. Let me know if you need any other neural network teaching tips. Here are some tips for teaching Python for AI to students in an introductory course. Give an overview of Python high-level language, easy-to-learn syntax, vast libraries and community support. Cover Jupyter notebooks, great for teaching Python interactively. Teach core language basics, variables, data types, functions, conditionals, loops, classes. Use simple examples and exercises. Introduce NumPy for numerical computing. Explain arrays, vector, matrix operations, broadcasting. Cover pandas for data analysis. Demo data frames, reading and writing data, indexing, manipulating. Teach data visualization with Matplotlib and Seaborn.
Show simple plots and customization. Introduce scikit-learn for machine learning. Explain its consistent API, estimators, model training. Demo TensorFlow, Keras for building deep learning models. Build and train a basic neural network. Set up coding exercises and projects for hands-on practice with the libraries. Encourage using Google Colab so students don't need to install anything locally. Focus on Python fundamentals and libraries relevant to AI. Guide students through debugging common errors and troubleshooting problems. Provide helper code, notebooks, datasets and learning resources for their reference. The goal should be to give students just enough Python skills to start applying AI rather than teach them to be Python experts. Coding exercise for Python. Here are some good coding exercises and projects to provide students hands-on practice with Python for AI. Linear regression. Use scikit-learn to implement simple linear regression on a dataset. Plot the fit line. K nearest neighbors. Classify iris flower species using KNN algorithm. Tune model hyperparameters. Neural network. Build a simple neural net with one hidden layer to classify handwritten digits using TensorFlow, Keras. Computer vision. Write a Python script to identify and draw contours around objects in an image. Natural language processing. Create a Python program to perform sentiment analysis on movie reviews using text blob. Data visualization. Load a dataset in pandas and create plots like scatter plot, bar chart, histogram using matplotlib. Practice data manipulation in pandas using exercises like filtering, grouping, aggregating, merging data frames. Use interactive visualization to build neural networks and tweak parameters to see effects. Kaggle challenges. Compete in machine learning coding challenges on Kaggle using sample datasets provided. Python mini projects. Build mini projects that solve real-world problems, like a chatbot, recommendation system, image classifier. These exercises cover the key libraries like Pandas, Matplotlib, TensorFlow, scikit-learn and help solidify students' understanding by applying Python coding skills. You can provide datasets and skeleton code for them to complete. Here are some tips for teaching linear regression in an intro AI course. Explain regression as predicting a continuous target variable based on input features. Introduce the linear regression equation with coefficients, variables, and error term. Visualize it as a line of best fit. Use compelling real-world examples like predicting house prices, stock prices etc. Walk through an example linear regression model in class using Python and sklearn on sample data. Explain fitting, prediction, evaluation. Explain ordinary least squares as the method to learn coefficients. No need to derivations, focus on intuition. Evaluate model performance using metrics like MAE, MSE, R-squared. Interpret values. Visualize results using a scatter plot with regression line overlay. Useful to build intuition. Cover model assumptions linearity, no multicollinearity, homoscedasticity, normality of errors, briefly. Extend to multiple linear regression with multiple input variables. Add dimensionality. Show how to prevent overfitting using regularization techniques like L1 and L2. Provide coding exercises to implement linear models, evaluate performance, NLP. Here are some tips for teaching NLP concepts in an intro AI course. Explain common NLP tasks: machine translation, sentiment analysis, text summarization, chatbots etc. Use relatable examples. Introduce text preprocessing, tokenization, lemmatization, stop word removal, TF-IDF etc. Show examples in code. Cover major algorithms like naive Bayes, SVM, neural nets for NLP. No need to dive into mathematical details. Demonstrate building a simple bag of words model with sklearn in class. Explain vectors, matrices. Discuss representing words as vectors, embeddings and using pre-trained word vectors. Explain RNNs, LSTMs and CNNs for sequential text data at a high level. Show applications like sentiment classification of movie reviews using Python. Introduce libraries like NLTK, Spacy, Text Blob for common NLP tasks. Cover text similarity techniques like cosine similarity, edit distance and applications. Discuss NLP best practices like handling punctuation, casing, spelling, stemming, emojis. Talk about challenges like sarcasm, ambiguity, entity recognition. Include NLP in coding projects and assignments for hands-on learning. The goal should be to give a practical introduction to key NLP concepts and applications without going too deep into math and theory. Focus on high-level ideas and implementation. Tell me more about NLP preprocessing. Here are some tips for teaching students about text preprocessing in NLP. Tokenization. Breaking text into individual words or tokens. Demo word and sentence tokenization in Python using NLTK. Lowercasing. Converting all text to lowercase to treat same words uniformly. Use lower in Python. Punctuation removal. Improves consistency. Removing common words like the, that don't add value. Use NLTK's top words list. Reduce words to base or dictionary form. Explain the difference between stemming and lemmatization. Noise removal. Remove extra white spaces, Unicode, URLs, hashtags, @ mentions. Spell correction. Use libraries like TextBlob to correct misspellings. Helps reduce sparsity. Part of speech tagging. Assign syntactic category like noun, verb, adjective to each token. Use NLTK's POS_tag. The goal is to clean and normalize raw text into a more structured format for further analysis. Give hands-on examples in Python showcasing each technique. Understanding preprocessing is crucial in NLP. Here are some tips for explaining machine translation in an intro NLP course. Explain the goal of machine translation: automatically translating text from one language to another using software. Discuss challenges like context, tone, grammar, gender, ambiguities that make it difficult. Cover the evolution from rule-based to statistical to neural machine translation, NMT. Explain the sequence-to-sequence encoder-decoder architecture commonly used in NMT. Introduce important models like RNNs, LSTMs, and attention mechanisms that made NMT effective. Provide examples of NMT applications like Google Translate, DeepL, Amazon Translate. Let students try them out. Show live NMT demos using pre-trained models in Python to translate simple sentences. Discuss how large parallel opera, growth of computing power, neural networks improve translation quality over time. Talk about challenges like rare words, named entities, word order differences. Cover best practices for preparing data and evaluating NMT model performance. Point out open challenges and active research in areas like low-resource languages. The goal should be to explain the landscape of machine translation, seminal advancements, and demonstrate simple examples rather than focus on mathematical details and complex models. Tell me more about TensorFlow. Here are some tips for teaching TensorFlow in an intro AI course. Explain TensorFlow as an open-source library for building and training milliliter models, especially neural networks. Introduce key TensorFlow concepts like graphs, sessions, tensors, variables, placeholders, operations. Show how to initialize tensors and variables and run simple operations like addition, matrix multiplication. Demonstrate building a simple sequential model with dense layers in Keras API. Train the model on sample data like MNIST digits to classify images. Explain model compilation steps like loss function, optimizer, metrics. Cover fitting model with .fit method and generating predictions. Show how to evaluate model performance on test data using accuracy, loss metrics. Visualize model training with TensorBoard metrics like loss, accuracy over epochs. Explain overfitting, underfitting, regularization, dropout techniques. Deploy trained model for inference using TF, function and TensorFlow serving. Use TensorFlow Playground to build intuition about neural network behavior. Assign hands-on projects to build TensorFlow models for problems like regression, classification. Emphasize key milliliter, DL concepts and implementing models end-to-end rather than focusing too much on TensorFlow syntax. The goal is to give them the foundation to start applying TensorFlow. Tell me more about milliliter algorithms. Unable to reach PO. Tell me more about coding exercises. Here are some additional tips for creating effective coding exercises for teaching machine learning algorithms. Focus on one algorithm at a time in each exercise to reinforce understanding. Provide a clear problem statement that is relevant to a real-world use case. Include tasks for data exploration, visualization, pre-processing before modeling. Provide skeleton code with hints to fill in key parts like model training, evaluation. Have them implement models from base libraries like scikit-learn, Keras rather than from scratch. Include tasks for hyperparameter tuning, error analysis, and improving model performance. Use popular datasets like IRIS, MNIST, housing, tweets for easier implementation. Increase complexity gradually from linear models to ensemble methods to neural networks. Make separate coding exercises for supervised,
sample solutions for comparison and include a rubric for assessment. Encourage creativity by allowing open-ended enhancement of the base model provided. Foster good coding habits through documentation, modular code, and commenting. The goal is to transition theoretical knowledge into practical experience through these coding challenges. Make sure to provide feedback and support as students work through them. Tell me more about skeleton code. Here are some additional tips for providing effective skeleton code for machine learning coding exercises. Import all required libraries and datasets up front so students don't struggle with environment setup. Provide a modular template with separate functions for data loading, pre-processing, training, evaluation. Include doc strings that explain the purpose of each function and any arguments they take. Add comments indicating where students need to write logic for the model implementation. Leave placeholder variables for hyperparameters that need to be tuned. Implement basic data preprocessing like train test split, normalization, encoding for the student. Have basic data visualization like plots, confusion matrix ready with blank axes and titles. Provide code for performance metrics like accuracy, precision, recall but leave implementation blank. Include boilerplate code for reading CSVs, JSON if external data needs to be loaded. Set up standard validation routines like k-fold cross-validation to be implemented. Leave repetitive code blocks like batch training, prediction loops, validation to the student. Utilize your own custom helper, utility functions that students can leverage. Ensure modularity so code sections can be reused across modeling techniques. The goal is to reduce redundant coding while letting students focus on the new concepts. Stub out as much boilerplate as possible and provide guiding comments in the skeleton. Here are some additional tips for providing effective skeleton code for machine learning coding exercises. Import all required libraries and datasets up front so students don't struggle with environment setup. Provide a modular template with separate functions for data loading, pre-processing, training, evaluation. Include doc strings that explain the purpose of each function and any arguments they take. Add comments indicating where students need to write logic for the model implementation. Leave placeholder variables for hyperparameters that need to be tuned. Implement basic data preprocessing like train test split, normalization, encoding for the student. Have basic data visualization like plots, confusion matrix ready with blank axes and titles. Provide code for performance metrics like accuracy, precision, recall but leave implementation blank. Include boilerplate code for reading CSVs, JSON if external data needs to be loaded. Set up standard validation routines like k-fold cross-validation to be implemented. Leave repetitive code blocks like batch training, prediction loops, validation to the student. Utilize your own custom helper, utility functions that students can leverage. Ensure modularity so code sections can be reused across modeling techniques. The goal is to reduce redundant coding while letting students focus on the new concepts. Stub out as much boilerplate as possible and provide guiding comments in the skeleton. Tell me more about machine learning algorithms. Here are some tips for teaching key machine learning algorithms in an introductory AI course. Linear regression. Explain regression for predicting continuous values. Intuitively explain minimizing cost function and gradient descent. Implement simple linear regression in code. Logistic regression. Describe classification for discrete outputs. Explain sigmoid activation and cross-entropy loss. Code binary logistic regression. K-nearest neighbors. Introduce instance-based learning. Explain proximity-based prediction and impact of K. Implement KNN algorithm and evaluate performance. Naive Bayes. Cover probabilistic modeling and Bayes' theorem. Explain naive assumption and likelihood calculation. Code naive Bayes classifier. Decision trees. Discuss tree-based modeling. Explain decision nodes, branches and leaf nodes. Implement ID3 CART algorithm. Discuss overfitting. SVM. Introduce concept of hyperplanes and margins. Explain support vectors. Implement soft margin SVM. Discuss kernels. Explain unsupervised learning and clustering. Discuss cluster prototypes and cost function. Implement K-means algorithm. Reinforcement learning. Provide intuition behind agents, environments, rewards, policies. Implement basic Q learning. Focus more on high-level concepts and simple coding rather than mathematical derivations. Contrast the strengths and weaknesses of each algorithm. Assign projects to apply them. Introductory AI course. Here are some tips for structuring an introductory AI course. Overview. Provide a broad overview of AI history, applications, state of the field today. Cover basics like AI, ML, neural networks. Basic Python skills. Spend some time teaching Python basics, data structures, control flow, functions. This will be needed for coding. Math foundation. Cover essential math like linear algebra, probability, statistics, calculus at a high level. Emphasize intuition. Regression algorithms. Teach linear regression and logistic regression in depth with coding examples. Essential ML techniques. Classification algorithms. Cover algorithms like naive Bayes, decision trees, SVM, KNN comprehensively with hands-on examples. Clustering. Explain cluster analysis techniques like K-means, hierarchical clustering. Natural language processing. Introduce NLP tasks like sentiment analysis. Teach bag of words, embeddings. Neural networks. Explain nonlinear activation, backpropagation at a high level. Implement simple neural nets. Deep learning. Provide an overview of CNNs, RNNs, applications like computer vision, NLP. Reinforcement learning. Cover core concepts like Markov decision processes, Q-learning. Assignments. Include coding projects, Kaggle competitions to provide implementation experience. Focus on high-level intuition and coding skills rather than advanced math and complex models. Emphasize applications and practical knowledge.
Welcome to the world of AI, a branch of computer science that focuses on creating intelligent machines. These machines can perform tasks that typically require human intelligence, such as visual perception and speech recognition. AI requires large amounts of data to learn from, and it improves itself over time. There are primarily three types of AI. First, we have narrow or weak AI, designed to perform a specific task. Secondly, we have general AI, which has the ability to learn any intellectual task that a human can. Lastly, we have super AI, a hypothetical AI that surpasses human intelligence. AI has a broad range of applications, from voice assistants to self-driving cars. It's also used in chatbots and fraud detection systems, making our lives easier and more comfortable. AI development is a continuous process, and it's rapidly growing with each passing day.
AI has the potential to revolutionize the way we live and work, solve complex problems, and eliminate the need for human intervention in various fields. However, it also raises certain ethical, legal, and social issues that need to be addressed before it becomes a reality.
AI future. Expansion into more complex real-world applications like self-driving cars, medical diagnosis, smart cities. Advances in representation learning and neural architecture search to build more optimized and customized AI models. Reinforcement learning for decision-making in dynamic, complex environments. Rise of AI system coordination instead of competition through collaborative agents. Improved human-AI interaction through natural language and computer vision. Ethical application of AI to avoid bias, promote transparency and accountability. Applications. Healthcare medical diagnosis, drug discovery, robotic surgery, virtual nursing assistants. Business predictive analytics, personalized marketing, improved efficiency and automation. Finance fraud detection, algorithmic trading, loan approval, chatbots for customer service. Transportation self-driving vehicles, traffic optimization, logistics and scheduling. Entertainment movie recommendations, music, game generation, conversational bots. Security malware, intrusion detection, surveillance, authentication. Education adaptive learning, grading automation, student engagement monitoring. The possibilities for evolving and applying AI are truly endless. Tell me more about drug discovery. Here are some key ways AI is being applied for drug discovery. Virtual screening AI models can rapidly screen billions of chemical compounds to identify promising candidates for a disease target. This significantly accelerates the molecule selection process. De novo drug design generative AI models can create novel molecular structures from scratch that have desired pharmaceutical properties. This expands the search space for potential drug compounds. Target identification analyzing gene expression data using AI can help identify new biological targets and disease pathways to focus on. Preclinical testing AI can analyze data from drug tests on cell cultures and animal models to predict toxicity, absorption rate and efficacy. This optimizes selection for clinical trials. Clinical trials AI can assist in trial recruitment, optimize dosing, monitor adherence, and assess patient health status during trials. This improves trial efficiency and safety. Drug repurposing machine learning models can uncover new uses for existing drugs by analyzing clinical data, patents, and publications. This speeds up approval. Manufacturing AI can optimize biomanufacturing processes for consistency and yield. It can also perform quality control on drug products. Overall, the use of large datasets, modern machine learning methods, and computational power enables AI to significantly accelerate the drug discovery pipeline and reduce costs. It holds great promise for developing new life-saving medications more efficiently. Tell me more about predictive analytics. Here are some additional details on using AI for predictive analytics. Forecasting time series models like ARIMA and PROFIT can predict future sales, demand, and other metrics based on historical data. Churn prediction identify customers likely to cancel a subscription using classification algorithms like logistic regression on usage, engagements, and survey data. Recommendation systems collaborative filtering and content-based filtering algorithms can suggest products and content to users. Example: Netflix, Amazon. Predictive maintenance based on sensor data from machines. Failure patterns can be identified via anomaly detection to optimize maintenance schedules. Fraud detection supervised models trained on past fraud data can flag suspicious transactions and accounts. Example: credit card fraud. Sentiment analysis using NLP techniques like text classification. Analyze customer sentiment from reviews, social media, surveys, etc. Model interpretability with methods like SHAP and LIME. Explain what factors drive predictions from black box models like neural networks. Uplift modeling. Estimate incremental impact of a treatment on user actions through techniques like two-model approach. Lead scoring. Rank and prioritize sales leads using regression or weighted models considering demographics, interests, and interactions. The key benefit of predictive analytics is identifying risks and opportunities proactively from data. This supports data-driven decision-making.